Hi, and welcome to today's video lesson. Today we're going to talk about solving absolute value equations and inequalities. So first, what is an absolute value? Well, an absolute value is the positive distance a number is from zero on a number line. So when you're talking about distance, you normally wouldn't say, if you were talking about how far it is from home to school, you wouldn't say it's a negative 3 miles, for example. It would be a positive 3 miles. And so distance, we always talk about being positive, even if you're talking about how far do you go from home to school and then back home. Well, just because you end up back at home doesn't mean you've gone 0 miles total. It's whatever the distance is from home to school, and then it's the same distance back home. So you would take both of those and add them together. So it's always the positive distance for absolute value. And our other term is an extraneous solution, and we'll get into some examples of extraneous solutions here in a bit, but it is a solution of an equation derived from the original equation that is not a solution to the original equation. Okay, so let's talk about a couple of examples here. First, here is a basic example of absolute value. The absolute value of negative 2 is positive 2. And if we look here, the distance from negative 2 to 0 on the number line is 2 units. So the absolute value of negative 2 is positive 2. So now let's take a look at some equations here. First of all, we'll start out with a kind of a basic equation. The absolute value of x is equal to 3. Well, notice that there are two numbers that are 3 units away from 0 on the number line. It would be negative 3 and positive 3. And so when we write this, we could say that x is equal positive 3, because when we put in positive 3 here, the absolute value of positive 3 is 3. And the absolute value of negative 3, because it's 3 units away from 0, that distance is also 3. So we have two possible solutions here. And you will find that when we're working with absolute values, we should always come up with a couple of solutions, unless, for example, if this was 0, the absolute value of what number is 0? Well, there is no positive or negative 0, so it would just be one solution in that case. But you could have up to two solutions in any of these equations. So let's take a look at another, maybe a more complicated equation. The absolute value of 2x plus 1 is equal to 7. So to solve that, what we have to do is split that up into two separate equations. We're going to make it 2x plus 1 equals 7. So just copy the problem as it is without the absolute values. But remember, if this is negative 7 inside of here, when we take the absolute value, it is still positive 7. So we could also say 2x plus 1 is equal to negative 7. Okay, so when we solve those, just solve them algebraically like you normally would. So subtract 1 from each side, you get 2x equals 6. Divide both sides by 2, you get x equals 3. And over here, when we solve this one, notice it's going to be the same steps for solving it. So subtract 1 from both sides, you get 2x equals negative 8. When you divide both sides by 2, you get x equals negative 4. So of course, when we're working, we always want to try to check our answers. So when we put positive 3 back in here, 2 times 3 is 6, plus 1 does give us 7. So this solution works. And when we put in negative 4, 2 times negative 4 is negative 8, plus 1 is negative 7, but the absolute value of negative 7 is positive 7. So we've checked both of our solutions. They do both work. Okay, example 1c. We're going to solve this equation, 3/4 x minus 1 equals 8, or the absolute value of that equals 8. So, again, divide it up into two separate equations. 3x, or 3/4 x minus 1 equals positive 8, or 3/4 x minus 1 equals negative 8. And we're going to solve each of those again. So just like before, it's going to be the same steps for both of these. So add 1 to both sides. Here you get 3/4 x equals 9. And remember, when we have a fraction in front of x, we just want to multiply by the reciprocal. So flip over 3/4, we get 4/3. So multiply both sides by 4/3. And we get 9 times 4/3 is 12. So we get x equals 12. Or here, if we add 1, we get negative 7, so 3/4 x equals negative 7. Multiplying by 3/4, we get not as nice of a number, negative 28 thirds. But we can deal with that number. Just go ahead and plug in the negative 28 thirds. Notice we can cross cancel the 3's here. So negative 28 divided by 4 is negative 7. Negative 7 minus 1 is negative 8. And the absolute value of negative 8 is 8. And here is our check for positive 12. So 3/4 times 12 is 9. 9 minus 1 is 8. So both solutions again work. Okay, so now let's get a little more complicated equation yet. So now here's a multi-step absolute value equation. So we want to solve this absolute value of 2x plus 5 equals 3x. Okay, so again, split it up into the two separate equations. Just for the first one, just rewrite the equation, 2x plus 5 equals 3x, and on the other side, just multiply by negative 1. So 3x plus 5 equals negative 3x. So over here, we're going to subtract 2x from both sides, and we get 5 equals x. And if we subtract 2x on this side, we get 5 equals negative 5x. So divide both sides by negative 5, we get x equals negative 1. And so here I have checked both of those solutions. When we put in 5, 2 times 5 is 10, plus 5 is 15, and that is equal to 3 times 5, which is 15. And on the other side, 2 times negative 1 is negative 2, plus 5 is 3, and 3 times negative 1 is also negative 3. Uh-oh, what happened there? We have absolute value of 3 is equal to negative 3. Well, that one doesn't work. So this is where our extraneous solutions come in. So this particular one, negative 1, is not a solution because when we plug it back in, it gives us something that's not true here. 3 is not equal to negative 3. So that's an extraneous solution. So we would write that negative 1 is an extraneous solution. Okay, so another example. Solve 4x, absolute value of 4x minus 1 equals 2x plus 9. So again, we need to rewrite the two equations. So write it just as it is, or write it with a negative sign out front on the other side. Now, the thing to be careful of here is we do have to put this in parentheses to remind us that we have to distribute the negative sign. So on this side, if we subtract 2x from both sides, we get 2x minus 1 equals 9. Adding 1 to both sides, we get 2x equals 10. And then divide both sides by 2, we get x equals 5. And when we check that, 4 times 5 is 20, minus 1 is 19, and 2 times 5 is 10, plus 9 is also 19. So this one works. Let's check the other one. So remember, we do have to distribute this negative sign on through. So negative 2x minus 9. And now when we add 2x to both sides, we get 6x minus 1 equals negative 9. Adding 1 to both sides, we get 6x equals negative 8. So we have to divide both sides by 6 to solve for x, and we get x equals negative 4 thirds. So let's put that back in. Negative 4 thirds times 4 is negative 16 thirds, and negative 16 thirds minus 1. Well, 1 we can rewrite as 3 thirds, so we have a common denominator. So I've done that here. Negative 16 thirds minus 3 thirds is negative 19 thirds. And when we take the absolute value of that, of course, we get positive 19 thirds. On the other side, we get 2 times negative 4 thirds, which is negative 8 thirds, plus 9. So we have to think about, well, what number plus 9? We need a common denominator here. So 27 over 3, 27 divided by 3 is 9. So 27 thirds would give us our common denominator. Negative 8 thirds plus 27 thirds is 19 thirds. So that works as well. Okay, so now we're going to switch gears just a little bit. We're going to go on to inequalities now. And I've listed some things here. You might want to jot these into your notes to help you rewrite your inequalities. So if we have the absolute value of, say, ax plus b is less than c, all we have to do when we have less than is take the number over here and do the opposite of that number and write it over here. So we get negative c is less than ax plus b is less than c. Or the same thing when you have less than or equal to. Now when we have a greater than, that's a little different story. We have to treat it a little bit differently. We have to go ahead and write it as our two separate equations. Now notice ax plus b is greater than c. I have that here. But remember, when we have an inequality, when we multiply by a negative number, we have to switch the sign around. So that's what happened here, is since we multiplied this by -1, we have to switch this sign. So ax plus b is less than negative c, or ax plus b is greater than c. And same thing if we have less than or equal to, or sorry, greater than or equal to here, we need to rewrite it as greater than or equal to and less than or equal to. Okay, and here is what the graph of each one of those will look like. So if it's less than, we're going to have just one interval here, one area for our solution, and we're not going to include our endpoints. If it's less than or equal to, we're going to have the same area, just our endpoints will be included. But when we have greater than, we have two regions for our solution. We have less than some number and then greater than some other number. And so same here. So let's go ahead and look at an example of that. Solve 4x plus 5 is greater than 13. So remember, in this case, since we have a greater than, we're going to divide it into two different equations again. So we have 4x plus 5 is greater than 13, or 4x plus 5 is less than -13. So we're going to solve each of these. Subtracting 5 from both sides, we get 4x is greater than 8. Dividing both sides by 4, we get x is greater than 2. And on the other side, if we subtract 5, we get 4x is less than -18 fourths, which, -18. Getting ahead of myself. Now if we divide both sides by 4, we get x is less than -18 fourths, and we can reduce that to 9 halves, -9 halves. So I have graphed that solution here. X is greater than 2 is over here, and 9 halves is 4.5. So -4.5 here, and it's less than that. And so to check that, we can use some number kind of in between the two. So I'm going to say, let's check a number here, and we want to make sure that our when we check it, it ends up being false, because 0 is not part of the solution set. So if we put in 0, it should be a false inequality. So 4 times 0 is 0, plus 5 is 5. 5 is greater than 13. That is false, which is what we want. We want it to be false because we picked a number that was not in the solution set as a test. Okay, let's do one more here with a greater than. This time it's greater than or equal to 1. So the absolute value of 2x plus 7 is greater than or equal to 1. So rewrite 2x plus 7 is greater than or equal to +1, or 2x plus 7 is less than or equal to -1. And again, just solve like normal. So subtract 7 from both sides. We get 2x is greater than or equal to -6. Divide by both sides by 2, we get x is greater than or equal to -3. And over here, subtracting 7, we get 2x is less than or equal to -8. Dividing by 2, we get x is less than or equal to -4. So since we have the equals on both of these, we go ahead and fill in the dots. Less than or equal to -4, greater than or equal to -3. And again, let's pick a number that's, so we don't have to do multiple tests. We'll just pick a number that's kind of in between here. How about 3.5, which we can rewrite as 7 halves? So 2 times -7 halves, since we're in the negative. 2 times -7 halves plus 7. Well, that's -7 plus 7 is 0. And 0 is not greater than 1. And again, we want it to be false because the number we chose to test was not in the solution set. So it's okay that it's false here. So we were able to check our answer correctly. Okay, just a couple more solutions. This time we're going to have a less than. So absolute value of x plus 2 is less than 6, and we're going to graph the solutions. So remember, since it's less than, all we have to do is add another sign here and make it -6. So we just have one big compound inequality. So -6 is less than x plus 2, which is less than +6. And so when we solve these, if we do something, we want to get x by itself in the middle, of course. And so if we do something, we're going to do it to all three areas. Just like if it was an equation, we would do something to both sides of the equation. Well, here, think of this as being three parts to our equation. So in this case, we're going to subtract 2. So to do that, we need to subtract 2 from here, and from here. So from all three places. So -6 minus 2 is -8, is less than x. And 6 minus 2 is 4. So we have -8 is less than 6, or x, which is less than 4. And so when we graph that here, we have this. Now this time we can use one number to check our solution. If we try 0 as a test, put in 0 for x, 0 plus 2 is 2. 2 is less than 6, and so we're okay there. Okay, one last example. Solve absolute value of 1/2 x minus 8 is less than or equal to +4. So notice this time we have less than or equal to, so we're going to put another less than or equal to symbol over here and take this and make it negative. So -4 is less than or equal to 1/2 x minus 8, which is less than +4. And again, if we do something to one part, we need to do it to all three. So in order to get x by itself, we need to, of course, add 8 first. So add 8 to all three parts. We get 4 is less than or equal to 1/2 x, which is less than or equal to 12. And now, to get rid of the 1/2, think and multiply by the reciprocal, which is half reciprocal of 1/2 is 2. So flip it over, we make it 2. So we're going to multiply all three parts by 2. So 4 times 2 is 8. 1/2 x times 2 is just 1x. And 12 times 2 is 24. And so we get our solution here, our graph. Remember to fill in both parts. Since it's less than or equal to, we're going to have everything filled in here. And we need to pick a number to test, to check our answer. So let's try 10. 10 seems to be a good number to use. So 1/2 of 10 minus 8 is less than or equal to 4. Well, 5 minus 8 is -3. And when we take the absolute value of -3, it's +3. And 3 is less than or equal to 4. So it does check out for our example. Okay, so that's it. That's all we have for today. I hope you enjoyed the lecture, and I'll see you again soon.